this video, I'd like to present the full arch workflow using the Shining Aoral Scan 3 intraoral scanner. And in this workflow, we're doing a conventional digital workflow. So we're using conventional scan bodies, and I have typed it onto here with 4 implant positions that we're going to work with. So first of all, we're going to set up the workflow on screen. So I've selected the patient. We specify that it's an implant workflow, and then we're going to specify that it's a full upper jaw. We could select individual units, but no, and define a bridge, but we'll select that it's a full upper jaw, and the software then specifies by minimum, at a minimum, there are 2 implant positions, but we want to add additional implant positions. We got 4 in total. So we're going to hit once one of those implant positions is highlighted, we can then hit the control key and then select the other 2 implant positions. So in this case, we've got 4 approximating there at incisors and molars on each side. So we've got our 4 implant positions marked. The implant base, to be fair, doesn't really matter what we select. I suppose screw retained is a good one to select here, but we would always, in a case like this, we'll have a communication with the lab and there'll be conversation going on there, so we don't have to dwell on being super specific about our instruction here, but we could put in a little note here: case as discussed, using ELOS scan bodies IO 2, let's just confirm that, 2CA, IO 2C. Of course, the lab will be forever grateful for the level of detail being provided there. And of course, we may even put in Nobel, RP, MUA. Wonderful. So the material, of course, can be specified as well. So we might go that it's zirconia, it's a zirconia bridge, and the tooth shade. Again, it's a full arch, so we might not just be specifying a single shade. Of course, there might be accompanying photographs or whatever else you might provide with it. So, and the bare basic information is important. The key thing is, of course, the 4 implant positions. That ultimately, that's the key thing. So we'll move on to the scan page, and the software is now guiding us through the workflow. So we scan the upper jaw with scan bodies, scan the lower jaw, and scan the bite. So for the purpose of the exercise, just going to scan the upper jaw, so we don't need to worry about the lower jaw, nor do we need to worry about the bite. So the first step is scan the upper jaw. We're scanning a model, so we're not working in the intraoral environment, so we will turn off intraoral environment here, which of course turns off the intelligent scan option. We could alternatively just turn off intelligent scan, but it's kind of good to work with these options down here. And then we'll pick up the scanner and we will start scanning in our normal scan process. So into position, and we start scanning the occlusal surface. We'll work around, we'll capture more of the palatal aspect and of the buccal aspect as well. What's really important to bear in mind is that we may be doing further alignments with this data, or the lab might be doing further alignments with this data. So it's really important to capture as much information as possible. So go beyond, go to the ridge and go beyond. So we've got the scan data complete. We can turn the color on if we wish. You can see we've got some finger in there, which of course we can remove with the isolated data option. And so I'm super happy with that. So I'm going to click on finish, and that will finish the scanning process for the arch. What the software has now done, it's very important to bear in mind what the software has done as we look at the workflow up here at the top. The software has moved on to the next stage, which is upper jaw with the implant. So it's made a copy of the upper jaw, and it's now asking us to delete or dig, I think is the language that they like to use, to dig out the areas where the implants are, because what we're going to do is do another scan with the scan bodies in place. So we want to kind of free up that area. So I get into position, double click, the software deletes. Double click and the software will delete. And I can use the pan option with my mouse and double click, the software deletes, and double click and the software deletes. It's really important. We don't want to delete too much because we want to maintain as much data as we possibly can. But equally, we don't want to delete too little either. Now here's a situation that might apply whereby you've scanned with the provisional denture in place. And if that was the case, you could end up with the provisional denture sitting in situ here. So if we did want to get rid of any remnants of the provisional denture, we can just double click all the way around the arch and get rid of all that. But of course we're losing reference points. So if you don't need to do it, I would say don't do it. So I'm going to hit reset and we go back in and we'll re-dig those areas. So double click, left and right mouse button to pan, double click and double click. Okay, all done and finished. Now we're ready, the software is ready for us to move on to the next stage of scanning. So we put the scan bodies in place and we'll tighten them up. And if you're familiar with this particular one, the ELOS one, we've got a conical body that kind of tapers down slightly. Cylindrical body that tapers down slightly. We've got a very flat surface at the top with a flat edge for indexing and a very small hole. So we do use the ELOS driver with this. And the idea with the very small hole for the very small driver is that we're maintaining a large surface area on top of the scan body, which will aid the design software when it comes to aligning the scan body kits. So make sure we're happy with all of those. They're all in situ, and now we can continue the scanning process. So we now pick up the scanner again, and we're going to start off on a reference point, whether that's towards the posterior region of the arch or maybe work to anterior. It doesn't really matter, but we need to pick up on somewhere the software will recognize us. We can see green box, the software recognizes where we are, and we move on to the first scan body. We roll the scanner around, wonderful. Move on to the next one, roll the scan body around, or roll the scanner around, the scan body should I say, then we'll move back again to the next one. Capture as much as we possibly can and steadily move over to the next one. When we've drifted off, we get a red box, so come back into situ and we continue on the scanning process there. So it's really important that we tried our very best to capture as much of the surface of the scan body as possible. Now, if it was a situation whereby you had two scan bodies and they were very close to each other, it might be very difficult. Or if it's a single scan body sitting in a single unit situation, you've got a tooth on each side, it might be very difficult to access and scan all that the surface of the scan body. But that's okay. Do capture as much as you possibly can. It's the best way to look at it. The one thing that we do need to be very careful about when scanning, and so we've often talked about stitching errors that can occur during a scanning process, and when the software sees something that's identical to something else, sometimes it can get confused, which is a natural and understandable situation. So we do need to bear in mind that we're scanning 4 scan bodies and each one of those is identical. So if we're not careful and we're not kind of following good practice, there is a risk that the software may get confused and say, well, it thinks one scan body is another, and then we can end up with some stitching errors. And they're okay, we can deal with those and we can address them once we spot them on screen. So it is really important that whilst we're scanning, we're keeping a focus in the mouth, but we're also keeping a good sharp focus on what's happening on screen as well. And one last point to bear in mind when we're scanning scan bodies particularly is try and keep the scanner above the scan body. Okay, so by a couple of millimeters. So with a lot of scanners, the tip itself is hollow, and the scan body can go inside the tip, and we want to avoid that if at all possible. So even on screen, so here we are, we're sitting above the scan body, perfectly fine. But as we bring this scanner closer to the scan body, what you'll now see, you can see it appear there in the top left hand side of the screen, is that a mirrored image of that scan body is starting to appear because we're so close. The scanner is sitting, the scan body is sitting inside of the tip, and therefore we can end up running a risk that we're going to start getting some stitching errors because the software is seeing 2 versions of the same thing, the actual image and a mirrored image. So always, as much as we possibly can, keep that scan body outside of the tip, or shall we say keep the tip as far away from the scan body as we possibly can. Okay, and once we're done, we can move on to the next step, which of course will be to complete the process, scan the lower arch, scan the bite, and go to the send page. So I hope that you found the video useful and informative, and it helps you with your scanning performance as well when working with conventional scan bodies in a full arch situation. Thanks for your time, and as always, if you have any questions, please do reach out to the support team at support@esmdigitalsolutions.com. Thank you and goodbye.